And we'll start with the first one, which is Dr. Kedar. He asked to drop his last name, but not the title. From Konica Minolta, about measuring and correcting micro-LED displays uniformities. Please, Dr. Kedar.
Hello, good evening. So I'll be quick. So I think I don't need to talk about micro-LEDs because everybody has spoken about them. So what I'm going to talk about is the way to characterize them and the challenges that are involved. So micro-LEDs, I mean, this is just an introduction slide which talks about where they are used and how they are used. So they are really growing technology with different, really, really high potential for AR, VR market, display market, and so on and so forth. But it is important nonetheless to characterize them. So in today's focus, what we are going to do is we are going to look at the display metrology. We will mainly focus on the display aspect of micro-LEDs and not AR, VR. But I mean, in AR, VR, they are mostly used as optical engines. So you can consider the AR, VR optical engine as also as a display, you know. So what do we inspect? So we inspect the emitter defects, like on the individual pixels. Then we inspect the non-uniformity of these displays, and then lastly is the transparency. So on the emitter level displays, you have, on the wafer level, you have what we call as missing pixels, dead pixels, or translation if the pixel is not in the right place, or the rotation if the pixel itself has been turned slightly. So all of these, let's say, defects can be easily identified and measured and eventually corrected. And I will come to the correction part in the later half or the later 2.5 minutes. So the non-uniformity challenge, what do we have here? So it's like on a pixel level, you can see variance in luminance because micro-LED is still, I would call it is mature, but it is still improving, and there are challenges when it comes to the uniformity on the luminance level. So we have seen, let's say, displays which show a wide variance of luminance because they are extremely bright. You can have easily a luminance variation from, let's call it 50,000 candela to 60,000 candela per meter square on a single display, which is probably less than a 2 centimeter size. So these kinds of individual pixel variation are of course challenging to the manufacturers. Then we also have the color dependency. We have seen, let's say, variation of 0.01 up to in, let's say, 1931 CIE curve. So we have seen significant color differences across the display. And this is just a 2 centimeter long. So this is again a challenge for metrologists as well as for the manufacturers. And then, of course, together you can call it as Mura, which is a classical display measurement technique where you have to get rid of the Mura and, or at least measure it and have it in the acceptable levels. So for the emissive display characteristics, one of the things also we have seen, there is also spectral variation on the emitter level, that means on the display level. You can see that on a single display, you can have 3 different wavelengths, though it is a monochromatic display. It is slightly exaggerated in this one, which is from 510 to 580. Of course, display manufacturers are not going to manufacture a display with that kind of variation, but just to emphasize the point, we have shown this kind of variation. But we have seen a variation of like 3 to 5 or even sometimes 10 nanometer across the display. So one of the